All right, problem number 8. There we go. Complete the 2-column proof. They tell me in this 2-column proof that we have 2 lines for our given information. So I'm going to take my given information and split it between those 2 lines. So on this top one, we have that segment AC bisects angle BCD. And on the next line down, we have that segment BC is congruent to segment DC. Let's go mark that on the picture. BC is congruent to DC. What do bisectors do? They cut things in half. What is being cut in half? AC is the thing doing the cutting. So AC is like the knife. Angle BCD. This angle right here is being cut in half. And that makes sense when I look at the picture because AC is like running right in the middle of that angle. So that means that this angle right here, angle 1 or angle BCA, is congruent to this angle right here, angle 2 or angle DCA. Angle BCA is congruent to angle DCA. How did we know that again? We saw bisecting. We're going to use that. What are we using about bisecting? The definition. What type of object was being cut? An angle. So this is definition of an angle bisector. So when I look at the picture, and I look at, say, this top triangle here, what do we have marked with congruences so far? Yep. We have a side, BC, and we have an angle right here. Can I use side angle to show those 2 triangles congruent to each other? No. I have to have at least 3 pieces, and at least one of them has to be a side. Is there anything in the picture that I'm allowed to mark as congruent even though it wasn't part of the given information? The shared side. What is my shared side? AC. I can mark it as congruent to itself because of the reflexive property. That's right. AC is congruent to AC because of the reflexive property. Now that I've added this other side, do I have enough information to say these 2 triangles are congruent to each other? Yes, using what? Using side, angle, side. The 2 sides run together and they meet at this angle that we have marked. So side, angle, side would be my last reason. My last statement is what it is that I am trying to prove. Triangle ABC is congruent to triangle ADC. All right. What else would you guys like to see? Number 9? Absolutely. Another proof. Number 9. I have two pieces of given information again. I have D as the midpoint of BC, and I have AB is congruent to CA. And because I don't have a whole lot of room on either of these lines, I'm going to put one piece of given information on each line, and I'll just use the reason of given twice. If I end up not having enough boxes, because I really should have put it on one line together, I'll just add a box at the bottom. So AB is congruent to CA, and D is the midpoint of BC. All right, none of that is marked up on my picture. AB, that's this, is congruent to CA, that's this. We were told that D is a midpoint. Well, if D is a midpoint of BC, what else would have to be true then? CD, yep, CD and BD would have to be congruent. CD is congruent to BD. Why? What'd you say? That's the thing. How did we know that CD and BD were going to be the same? Definition of midpoint, absolutely correct. Is there anything in the picture that I'm allowed to mark without being told? The shared side. AD is congruent to AD. For what reason? Reflexive property, yes. Do I have enough information to say that these two little triangles are congruent to each other? Yeah. Yes, using side, side, side. We can use side, 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 but you cannot use angle, angle, angle. We'll talk about that second semester. We'll look at what angle, angle, angle shows us. So let's write down the triangles that are congruent. That was next door, not us. I'm going to call the first triangle BAD. So triangle BAD is congruent to, what angle would correspond to B on the other triangle? C. So triangle C. A would correspond to A, so CAD. The last statement we want to make is what we're trying to prove. Angle ABD is congruent to angle ACD. What'd you say? Yes. These are two parts of two separate triangles. What do we call parts of triangles that match up? Corresponding. So corresponding parts of congruent triangles are congruent. We have to show this before we are allowed to use CPCTC. You have to show that the triangles are congruent before you can use CPCTC. What else would you guys like to look at? Yes. Number which one? 6. Number 6, absolutely. Desire, did you have one too? Which one? 10. So we'll do 6 and then we'll do 10. Number 6, if angle HAM and angle YMA are right angles, and HM is congruent to YA, name the parts that need to be proven or stated congruent to use the following. Okay, so first thing I'm going to do with this, do you guys see how there's a whole bunch of things going on in the picture? Like there's a bunch of little triangles. I want to zoom in on just two of these. So I'm going to copy this triangle. That would be triangle HAM. And I'm going to copy this one, which would be triangle YAM. Ham and yam. Thanksgiving triangles. They told me that angles HAM and YMA are right angles. So HAM, that would be this. So it's saying this is a right angle. And YMA, this angle right here, which on my original picture is here. And it also says that HM and YA are congruent. HM and YA are congruent. HM is directly across from the right angle, which means we would call that side a what? It's across from the right angle. What do we call the side of a triangle that is across from a right angle? Still haven't heard it yet. Starts with an H. What do we call the side of a triangle that is across from the right angle? It starts with an H. Hypotenuse, yes. And YA is across from a right angle here, so YA would also be a hypotenuse. If I wanted to use side, angle, side to show that these two triangles are congruent to each other, there's a couple different ways I could do this. We'll come back to this one. Hypotenuse leg is a little bit easier because we already have identified our hypotenuse, right? Then I would need to show that corresponding legs of these two triangles are congruent. So HA, what would that correspond to on the other triangle? YM. So if I could show that HA is congruent to YM, then I could use hypotenuse leg. Or there's another side that would be considered a leg. I don't have to go with HA. I could also do what? What's the other leg there other than HA? Same triangle, staying on the same triangle. I'm looking at this guy. This is a leg. Yep. AM. HM is the hypotenuse, and I want the leg. So AM could be a leg, and that would correspond to what on the other triangle? AM. So I could show that AM is congruent to AM. Either one of those would allow me to use hypotenuse leg. If I was going to use side, 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 I would need all three sides of triangle HAM to be congruent to their corresponding sides on triangle YAM. So I would need HA, congruent to YM, and I would need AM congruent to AM. Not an or anymore, I would need an and. If I was going to use side angle angle, I already have one pair of angles that are congruent to each other. A and M are congruent. To use angle angle side, or side angle angle, I would also need to know that angle H or AHM is congruent to, this is angle AHM right up here. What would that correspond to on the other triangle? This guy right here. And we have to name it with this in the middle. So MYA or AYM. But where we make that turn has to be the middle letter. So MYA. Or, what about if I wanted it to be the other angle? This angle and this angle. What could I name this one? HMA. Angle HMA. Congruent to, what would we call this one? YAM. All right. Let's go back to the first one that we skipped. To do side angle side, I would need, come on. Here's my hypotenuse. I would need sides on either side of my right angle. So I would need to know that side HA is congruent to, what would that correspond to on the other triangle? HA corresponds to YM. And I would also need AM congruent to AM. What two triangles are congruent? So now we're going to write our triangle congruence statement. Triangle, let's call the first one HAM. Yes, sir. Yes, you may. Is congruent to YMA. Triangle YMA. Make sure you're matching up the corresponding congruent pieces. I could have named that first triangle differently. I didn't have to do H at the beginning, but wherever H falls, that has to correspond with where Y is in the other triangle name. They have to be in the same positions. All right, number 10 was the next one we were going to go and look at. In triangle BRK, the measure of angle K is 7 less than 3 times the measure of angle B. The measure of angle R is 30 degrees. Well, they told me that one. I'm going to draw a triangle. Something like this. B, R, K. I know angle R is 30 degrees because they told me that. So I'm going to add that to my picture. It says angle K is 7 less than 3 times the measure of angle B. Do we know how big angle B is? Then what can I call it? X. So I'm going to add that to my picture. B is X degrees. K is 7 less than 3 times. 7 less than something. Is that 7 minus or minus 7? Minus 7. So something minus 7. 3x minus 7, yes. 3 times the measure of angle B, take away 7. So 3x minus 7. Whenever you see less than, it has to be minus and whatever that number is. Never that number and then minus. The 3 angles in a triangle add up to how much? 180. So the measure of angle B plus the measure of angle R plus the measure of angle K equals 180. Angle B is X. Plus, how big was angle R? 30. Plus, how big was angle K? 3x minus 7 equals 180. Combine like terms together, so I combine x and 3x together. Gives me 4x. And then we combine our constants. I have a positive 30 and a minus 7. What is 30 minus 7? So 4x plus 23 equals 180. What do I do now? Yep, we are going to subtract 23 from both sides. Close. Get 4x equals 157. And then we divide both sides by 4, and we get a whole number? No, that's okay. What do we get for x? 39.25. They didn't ask me to find x in this problem, though. They asked me to find what? Measure of angle B and measure of angle K. Well, we said that the measure of angle B was x. So how big is angle B? 39.25 degrees. Decimals do not automatically mean that it's wrong. Angle K is 3x minus 7, where x is 39.25. What is 3 times 39.25 minus 7? 110.75. Now we're going to classify this triangle. Angle R, 30 degrees. What type of angle is that? Acute. Because it is less than 90. What about angle B? That one is also acute. Angle K, obtuse. So is this triangle an acute triangle, a right triangle, or an obtuse triangle? It's an obtuse triangle. That's one piece of the classification. That's classifying it by its angles. Now we have to classify it by its sides. My choices there are equilateral, isosceles, and scalene. Scalene, why? Yep. All the angles are different, so that means all the sides are different. And when all the sides are different, that is a scalene triangle. So it's an obtuse scalene triangle. What else would you guys like to see? Yes. Number 11. Absolutely. In the diagram shown below, find x and y. So I have a bit of an issue when it comes to finding x. How many places does x show up? 3. Can I set 3 things equal? So I have to figure out which 2 things I can set equal. I need to know which sides are congruent. Do we know which sides are congruent right now? No. So let's see if we can find y. And then we'll see if we can use that to figure out which sides are congruent. Y is right here. Thank you. Yes, you should go get your stuff from your last period. This angle here, this 108, is that inside or outside the triangle? Outside. What do we call outside angles? Exterior. This is an exterior angle. So what do we call this angle and this angle? They are interior. Are they touching my exterior angle? No, then we add another word to that. Starts with an R. If you're not right next to something, you might want to use this to change the channel. Remote. These are remote interior angles. We learned an exterior angle theorem at the beginning of this module. The exterior angle theorem tells me that the exterior angle of a triangle is equal to the sum of the 2 remote interior angles. Questions dealing with exterior angles historically are the most missed questions on the test because we don't remember this rule right here. It's also the most missed question that we had on the first skills check. The outside angle, the exterior angle, is equal to the sum of the 2 remote interior angles. How big is that exterior angle? 108 degrees. Sum means to do what? Sum means to add. How big are the remote interior angles? 54 and y. So to figure out how big y is, I'm going to subtract 54 from both sides. What is 108 minus 54? 54. So there's one of the answers they asked me to find. And that's super informative. It is. Because tell me about these 2 angles now. They are the same. Let's mark them with a congruence marking. This one is the same as this one. If I have 2 angles that are the same, hold on just a second. If I have 2 angles that are the same, what type of triangle are we looking at? Isosceles. Isosceles triangles have two angles that are congruent and two sides that are congruent. We have to figure out which two sides it is. We know where our congruent angles are now. So which two sides would have to be the congruent sides? 7x minus 14, because that is opposite this top angle. And 2x plus 16, because it is opposite angle y. The sides that are opposite the congruent angles are congruent to each other. And what can we do with congruent things? Set them equal to each other. So 7x minus 14 equals 2x plus 16. Get the x's to the same side first, so I'm going to subtract 2x from both sides. What is 7 minus 2? So I have 5x minus 14 equals 16. Then I'm going to add 14 to both sides. What is 16 plus 14? 30. So 5x equals 30. What would x have to be then? 6. Just because they ask for it first does not necessarily mean you can solve for it first. We had to find y first, because that was the only thing we had enough information for. And then finding y allowed us to figure out what kind of triangle we were looking at, which allowed us to figure out which sides must be congruent to each other. What else would you guys like to see? I have time for probably 2 more, maybe 3 if they're short. Yes. Number 1? Absolutely. Given angle ABC is congruent to angle ABD. ABC is this angle right here, and ABD is this angle right here. So it says that those two angles are congruent. And then it also says that angles CAB and DAB are congruent. CAB, that's this angle up here, and DAB, that's this angle right here. It says those are congruent. What other piece of information do we know from the picture? What are we allowed to mark even though it didn't get included in the given? The shared sides. AB is congruent to AB. So now let's write a triangle congruence statement. Let's call this first triangle CAB. What would correspond to C on the other triangle? D. C and D are corresponding, so this has to start with D. Up at the top, A, that has 2 little congruence marks on it. On the other triangle, that's still A. So D, A, B. What congruence postulate or congruence theorem are we using here? Why can we say that these 2 triangles are congruent to each other? What's marked up? Look at just one of these triangles. Let's look at this one. What'd you say? An angle aside and an angle. Is the side sandwiched in between the 2 angles? Yes. So this would be angle side angle. Yep. It's technically a theorem. Angle, side, angle. If we wanted to use angle, angle, side, I would need to know that what other piece is congruent. Yes. Angle C is congruent to angle D. That would allow me to use angle, angle, side. I have time for probably one more, maybe two if they're short. Yes. Number 4, absolutely. Using the picture, find the angles. So the first thing they asked me to find is BDC. B down to D and over to C. Is that an inside angle or an outside angle? Outside. What do we call outside angles? Exterior. And we just spent a couple minutes talking about the exterior angle theorem. The exterior angle theorem tells me that my exterior angle is equal to the sum of the two remote interior angles. My exterior angle is angle BDC. So the measure of angle BDC is equal to, sum means I need to add. What are we adding? Where are my remote interior angles? Angle A. I need a sum, so I need another angle. And angle B. These, I couldn't hear you, are the remote interior angles. So 42 plus 37. What do you get when you add 42 and 37 together? How much? Not 78. 79. 79 degrees. This angle, angle BDA. BDA. That's this one right here. What do we know about these two angles? What do we call that special angle pair? What do we call angles that are side by side that together form a straight line? A linear pair. And linear pair angles always add up to 180. Well, we know that the other angle is 79 degrees, so 79 degrees plus the measure of angle BDA is equal to 180. So then I subtract 79 from both sides. How big is angle BDA? 181. Sorry, 101, not 181. 101. I do not have time for another problem unless it's like literally a 30-second problem. But the answer key is already posted in Canvas. I'll show you guys where that is. So on our Canvas page for today, Wednesday, 11/13, review for Module 5, test day 2. Scroll down on this page. The videos for the other class periods will be right here. As soon as they're finished rendering, they should go up in the next like hour or so. You can get in there if you had questions about ones that we did not go over in class. If you go all the way to the very bottom of the page, the Module 5 test review answer key is right here, and it has all of my work on it.